All right, so today we are going to do lessons 2.3 and 2.4. Okay, it is all basically working together to make box and whisker plots here. All right, so just some basic definitions here. Median just stands for the middle number, just like it did the first time you learned this back in elementary school. Quartiles. Quartiles just represent the numbers separated into quarters. All right, the first quartile represents the 25th percentile. Second quartile is the 50th percentile. That's also the median. And the third quartile is the 75th percentile. All right, and we're gonna figure out how to do those different things. Another one that we need to know is the interquartile range. All right, that represents the middle 50% of the data. So that is simply the third one minus the first one. So if you're thinking about a box and whisker plot, which we're going to do in a little bit, it's all the numbers that fall inside the box is what the interquartile range represents. Okay, so down below is something more important that we need. Okay, the interquartile range, you'll see that listed as IQR every once in a while, can help determine outliers. Okay, and we are going to figure out how to do those in just a minute here. But the equation for it is pretty much what is listed here. To figure out if a value may be an outlier, it would be less than 1.5 times the interquartile range below the first quartile, or more than 1.5 times the interquartile range above the third quartile. And like I said, I'm gonna show you how to do that in just a second. Next week. Let's see, either a Monday, Wednesday, or Friday. Probably not Monday, probably not Wednesday. Is that exact enough for you, Eli?
I don't know.
I'm pretty sure it's going to be Friday, but I will let you know for sure on Monday.
We're gonna have a work day.
Why would we have a work day? I know, today's going to be pretty rough. You almost have 20 questions to do.
Yeah, but there's probably like 30 questions, 30 ABCs in the 20 questions.
Maybe. It's okay. You're doing college stuff now.
Yeah.
That's true. You have been doing college stuff for a while. What? That's not necessarily true. It depends on the teacher.
What's up, man?
What's that? Homework. It depends on the teacher.
What's their online class?
Are we ready to go on here? All right, so listed below there, we have 13 different real estate prices. We need to calculate the IQR and determine if any prices are potential outliers. Okay, now the first thing that you should do when you get a list like this is you should order them from least to greatest. So that is our first step here. So I know it's just terrible putting 13 numbers in order. We can't put numbers in order now.
can I get rid of that?
I don't know.
Your razors are 19.
12, actually.
No,
Genghis Khan.
Gentlemen, close it. I said to put them in order. Let's go.
already got them.
I didn't write it down.
They're all good and calculated.
And then- All right, so if we put all 13 of those numbers in order from least to greatest, and that would be the order in the red there. Okay, so as you're reading that, that is your very first step. Okay, before you find your interquartiles, what you need to do is you need to find your median. Your median is what here? What are we trying to find?
Hello?
The middle number. So if we've got 13 numbers here, the middle number is going to be the 7th one. Okay, and so our median is that right there. Okay, now it's not part of our answer here, but it can be important to know with what we're going to have to do in a little bit. Okay, from there, we need to find the first quartile and the third quartile. All right, your first quartile is going to be everything below your median. You're going to find the median of that. Okay, so if we look at this, we've got 6 numbers here. The median of this, the median would be these two. So when you have 2 middle numbers like we do here, to find your first quartile, we're just going to add these 2 together and divide by 2. We're going to find the average of those 2. And that will give us, yes, Sarah. I wrote the median wrong. Oh, I did. Thank you for catching that. Better? Okay. All right, so our first quartile is 308,750. And once again, how we find that is we take the median of everything below our median. So we've got 2 of them, we just take the average of those 2. And then we also need to find the third quartile. All right, so we've got 6 numbers above our median, so we're going to have 2. Again here, 2 middle numbers, and we have to do the same concept. So 639,000 plus 659,000, and divide that by 2. So we end up with 649,000. All right, and then we have to find the interquartile range here. To find the interquartile range, we simply take the third quartile and subtract the first quartile. So we end up with 340,250. All right, any questions on that? All right, so then we're going to use that interquartile to figure out if we have any potential outliers. Okay, to find that, we are going to take our interquartile range and multiply that by 1.5. When we multiply that by 1.5, we get 510,375. All right, now how we use that is to find out if we have any outliers on the bottom half. We take our first quartile, so 308, 750, and subtract out 510, 375, and we're going to get a negative number here, right? If we have an answer that is less than that number, it's going to be a negative 201, 625. Do we have a number in our list that's less than negative 201, 625? No. Okay, so we don't have an outlier on the bottom part, but we could have an outlier on the top part. Okay, how we figure that out is we go with our third quartile and go 649,000. And then we're going to add this 510, 375 to it. And when we do that, we get an answer of 1,159,375. Do we have any numbers above that? Yeah, this 5.5 million is above that. So our outlier for this one is that 5.5 million. Well, now we have a mathematical way to prove that. Okay, now do notice that we did have this 1.095 million here is really close to this. And sometimes we may think that this might be an outlier also, okay? Based on the equation that we were just talking about here, that would prove that it would not be, okay? So a lot of stuff going on there. Okay, the math part isn't necessarily hard. It's adding, subtracting, multiplying, all right? But the order to do it is definitely new. You guys haven't done this before. Okay, any questions? So to find this, you got to find the median first. Then you got to find the first and third quartile. You're just finding the median of the stuff below and the median of the stuff above. Okay, if there's two medians, we have to take the average of those two. All right, to find those, to find the interquartile range, we just take quartile 3 minus quartile 1 to get that. Okay, to figure out what the plus or minus is to find our outlier, we just take that interquartile range times 1.5 and then add and subtract it to quarter 1 and quarter 3. All right, questions? All right, something new here. For this one, we have 50 statistics students. We're asked how much they slept the night before. Rounded to the nearest hour, the results are shown in our chart here. Okay, so we talked about those, how to find this last chapter. All right, so what this says here is we have 2 students that slept 4 hours a night. Okay, 5 students that slept 5 and so on. All right, what we want to find from this chart is we want to find the 28th percentile, the median, and the third quartile. Okay, so remember 28th percentile, that's just 28%. All right, the median would be exactly 50%. And the third quartile would be 75%. All right, now there's different ways to find this based on what you are given, okay? We're gonna talk about stuff in the next couple slides on how to find the exact number a different way. But for each one of these, we can kind of cheat our way to get our answer here based on what we're given. All right, if you notice here, 28th percentile, that is going to be talking about this cumulative relative frequency. All right, if you look at the end of the 6 hours here, we have the equivalent of 28%. All right, now To find the 28th percentile though, that means we are going to have to look at these numbers in particular. All right, and we're at the 28th percentile is going to be halfway in between this one and this one. All right, so halfway in between, we just take 6 plus 7 and then divide it by 2. The 28th percentile is going to be 6.5 hours here. All right. Questions on that? Okay, 28. You guys agree that the 0.28 is equivalent to 28th percent, right? Okay. So all the numbers above this would constitute our 28th percent. Okay. To find the actual number that would work for the 28th percentile, it's going to be halfway in between these two numbers here. All right, because if you look at this, so this is kind of like finding the median of all these numbers here. All right, and what we have here is we have 7, we have 14 out of 50, which would be equal to our 0.28. All right, and I got the 14 from adding these three together. All right, and then it's out of 50 students. So that's how you get that. All right, and then to find the 28th percentile though, okay, it's finding the median in between those. We would have an even number here. Whenever you have an even number, you're going to have to take one below and one above. You are finding the median of these two numbers. Okay, if this were, instead of 50, if this were 49 students, well, then it would just be the one because it would be an odd number. The problem here is that it's an even number. So we're going to have to take the two of them, add them together and divide by 2. All right. Look at this one back here. Okay. This one was odd, right? We started with odd. Hey, you got to listen, please. This one, we started with odd. To find our median originally, that's just going to be one of them, right? Because we would have 6 below them and 6 above them. This would be exactly in the middle, okay? To find the first quartile one, that's the median of what's left over of everything below. Well, there are 6 numbers that are below here, okay? Because that's an even number, we're going to have 2 numbers that we have to average together here. It's that same concept with what we're doing here. Because there's 50 of them, and this is exactly at the 28th percentile, we're going to have to take the 2 to find the median of those 2. All right. If this were 49, we would just have 1. Whenever it's odd, you're always going to have just that one median there. If it's even, you're going to have to take 2 to divide between. Okay, now, for example, down here for this 50 percentile, which is the same as the median. If you were to look at this, if we were to come down to this one here, this would be the same as the 52nd percentile. All right, what happens with this is all of the numbers in between the 28th percentile and the 52nd percentile, they're all 7s. So if we're going to take 2 of those, we would go 7 plus 7 divided by 2. Well, that's just 7 of them. Okay. All right. Once again, we're taking 2 of them because it's not 49, it's 50 of them. All right. Does that make sense? Sarah.
Okay, so like the median makes sense, but like still at the 28th percentile, since that's exactly that number, I don't get why you have to do that.
Okay. If
Wouldn't it just be 6?
no. If we were asking for the 52nd percentile, okay, that is right on the line in between those 2 numbers. Okay, so what would be in between these two numbers? The 52nd is not saying all sevens are the 52nd percentile. Okay, if we were to list these out, the 52nd percentile would be in between the last 7 and the first 8. Okay, the 28th percentile is after the last 6, but before the first 7. Does that make more sense?
Yeah.
Okay. All right. Yes, Abigail.
So what if you were looking for like the 27th percentile?
What do you think you do then?
Would it just be 6?
The 27th percentile, because it's not exactly this, it'd be a little bit less than that. It would be exactly 6. Yeah. Okay. The only time you truly have to do this, add the 2 together, divide by 2, is when it's exactly what you're looking for here. So like the 75th percentile then would be what? It'd be 8. Yeah. All right, because it's less than our 80% here, which would fall into our 8s there. All right. What's that? No, it can't go above. All right. So sometimes when you have a chart like this, sometimes you're able to figure it out just by looking at them. Okay. Other times you're not going to have the chart, so we got to come up with another way to do these. All right, which is what we're going to do next here. Okay, so write it down. Write down the whole thing there, and then we'll talk about how to solve this. Let's go. What's that?
Was it a new lesson?
No, it's the same lesson. We're still in 2.3. Gentlemen, right, let's go. All right, so I'll give you time to get this all copied down. I haven't figured out how important this is to memorize yet. Okay, so I'll let you know if this is something you have to get memorized or not as we go a little bit further here. But this is an equation to find out, you know, on the last page, we were able to look at the chart to be able to tell. Okay, sometimes you're just going to have a list of numbers like we have down below. And this equation is going to be a way to figure out exactly what the number is going to be for each one of those percentiles. Okay, so this might actually make a little bit more sense than the chart. All right, and our equation is just I equals k over 100 times n plus 1. The k is talking about the percentile. The I, they say the index, it's more like the position in the list from least to greatest. And then the n is the total number of data points. All right, so down below, we have a list of numbers from least to greatest here. All right, and once again, that's going to be something that you're going to have to do. That's one of your first steps you're going to have to do in your homework, is to put the numbers in order from least to greatest. I already did it for us, so we don't have to worry about that. All right, and then we just use the equation to figure out what number is going to be the 70th percentile here. All right, and we just plug stuff into this equation here. So we're trying to figure out what I is. So I equals, K stands for the percentile, so 70 over 100. And then our N stands for how many numbers we have? We have 16 of them. So we go 16 plus 1. And we just multiply those out.
What would it be if we didn't have a, how would we figure out the odd?
What do you mean?
Like, how would it tell us?
What are you asking me, Eli?
I'm confused.
Like if you're-
I'm confused by your question.
If you're trying to find K, it would give you 5.
That's on the next page. I'll show it to you. Okay. All right. So if we multiply these out, it is 11.9. Okay. And from there, let me check really quick to make sure I tell you the right thing. All right. So if you get an exact whole number there, that's easy to figure out. If you get a decimal, you round it to the nearest whole number. Okay, so this 11.9 is going to turn into a 12. Okay, so what that means is we're going to count up our list until we get to the 12th number. There's our 12th number. So our answer for the 70th percentile is 37. Okay, so if you're given the equation, it's just plugging stuff in, simplify it down, okay, round it properly. So if this was 11.4 instead, then we'd round it down to 11, and then we just count until we get to that digit. Okay, so for the next one, go ahead and do the 83rd percentile, please. All right, so for that one, you should get 42. That's what I got. All right, any questions there at all? Yes, Deidre.
So like, this formula should work for everything.
Yes,
But then like, so can I use it on the chart?
absolutely. That's what I was going to show you next here. All right, if we were going to go back to the 28th percentile, all right, and we just threw everything into that equation there. This is how well I know it. I don't know it well enough. I know it's 28 over 100 times n plus 1, right? So it's going to be 50 plus 1 here. All right, so that would be 0.28 times 51 would give us an answer of 14.28. We would round this down to 14, okay? And then we would just figure out what the 14th data point is here. All right, so the 14th would be, there's 7 of them here. It would be a 6, wouldn't it? Okay,
Oh my God.
so listen, please. So for this one, based on how you do it, remember how we talked about at the beginning of the chapter, that your statistics should be very similar no matter how you do it, but they don't have to be the same, right? Do you guys remember me saying that earlier? Okay, this would be an example. All right, we did it this way with our percentile equation that we just talked about, and we got a 6. Okay, we did it the other way, and we got a 6.5. Are either one of them wrong? No. Okay, but what should happen here, they're two different numbers, they should be fairly close to each other. If they are not fairly close to each other, one of the two ways is screwed up somehow. You got to go back and check it. Okay, so when you're doing this, when you're doing this on homework or on a test or something like this, you have to show me which way you want to go. okay, because both answers are technically right. All right. The reason why this one is 6.5 and this one is 6 is because we rounded this. All right. If this were exactly 14, if we divide this out and it's exactly 14, then you would have the same answer for both of these. Okay, but it's not. And that's the difference between them. It just has to do with how we rounded the numbers. Okay, that make more sense? I personally like the equation more, even though this is the first time I've used it in a really, really long time. Sometimes it can be super easy to find our numbers based on looking at a chart, but this equation works every time. Okay, like I understood why this answer was kind of confusing. All right, so if you want to use the equation every single time, go right ahead. Okay, now to answer Eli's other question is, what if we're given a number and we have to find the percentile? Right, that's more or less what you were asking. All right, this is what the equation is for that. No, that's good that you asked the question. And hey, you're thinking ahead, Eli. It doesn't happen very often. And just so you know, that list that I have down below there, it's the exact same list. So if you copied it down once already, you don't have to do it again. Yes, sir.
Is X saying like that is like the number of that value below the percent that you want to find?
It is, X stands for the number in your list that's below 27, for example. So 27 is here. It would be, for this one, it'd be a 5.
You heard me?
So why here or
That is a good question. All right, so our X, first of all, our X stands for all of the data points that are below what you're trying to find. So in this case, if we're trying to find the percentile for 27, that would be 5 of them. So if we start plugging in numbers for this, our X is 5 plus 0.5 times our Y value. The Y value says the number of data points that are equal to the data value you want to find the percentile for. All right, so what that means is, how many 27s do we have in the list? 1, right? Okay, now, if we came back to this chart, we would have multiples for each one of them, right? So your Y value would be whatever the frequency is, okay? So there are gonna be some times where you have them double up or triple up or whatever the case is. That's what you would put in for your Y value. All right, and then, so you take 100 times 5 plus 0.5, and then we divide it by total number of data points, which is 16. And that gets you a percentile of 34.375. And I am guessing, I gotta look it up. Yes. Yeah. Yeah.
Thank you.
All right. For this one, we don't have decimals in our answers for this, so we round it to the nearest integer. So this is not 34.375. It is, we round it properly to 34%. All right, so go ahead and find 36, please. All right, I got an answer of 66%. Any questions there? All right. Yes, Tina. Say that again. The one, how many 36s do we have in our list? Okay. All right. Any other questions here? All right. Okay. One last page. Okay. On a 20-question math test, the 70th percentile for the number of correct answers was 16. Interpret the 70th percentile in the context of this situation. Okay, so basically what this question is asking is, what does the 70th percentile mean? So if you got above the 70th percentile, how many answers did you get right? Over 16. Yeah, so that's one way that you can interpret this. Okay, so you would say if you were over the 70th percentile, then you had more than 16 answers correct. All right, what about if you had less than 70th? Then you had less than 16, right? Yeah, that's all that means, okay? Normally for these, we want to put both. We want to put over it and under it. Okay, do realize though that not always is the higher number. So like this, when we had more than 16, that meant your percentile went up, right? Is that always the case? What would be an example of when you were in the higher percentage, but the number actually got smaller? Can you think of one? Jacob? Correct. Yeah, that would be one way to do it. Okay. So if you were more than the 70th percentile, that means you had less than what? 4 incorrect answers. That'd be one way to put it. Okay. I was thinking just a completely different situation. Okay. Say like class rank. If you're in the 70th percentile of your class, Okay, if you were above the 70th percentile in your class, maybe you were like the 8th student and below, right? Does that make sense? Okay, if you were less than the 70th percentile in your class, then it would be above that 8th student and higher, okay? All right, we see that a lot of the time on when you guys got your ACT scores back, they would say, all right, your 36 got you into the 98th percentile. Okay, none of you got a 36. So I don't think you did. Okay. All right, you get what I'm saying though, right? All right, so that is 2.3. For these, you just have to say what it means. Okay, that's all this question is asking here. You're gonna see these in the homework. Just say what the 70th percentile means. Just put it into words. Okay. All right. 2.4 is all of one slide. Okay. We got to make a box and whisker plot. Okay. Sometimes they're called a box plot. Sometimes they're called a box and whisker plot. So that's what we're doing here. So if you want to copy these down, I know you guys have done this before. We talked about this in Algebra 2. This is more of a like a junior high thing, maybe an elementary thing. I don't know when the first time was you guys saw these, but we're going to talk about how to find these really quick. And it's going to line up with what we just did in 2.3 here. All right, so anytime that you do box and whisker plot, first of all, if you're going to do it manually, you have to put them in order from least to greatest. All right, and then important things that we're going to have to find. Okay, we are going to, for a box and whisker plot, we need 5 points. Those 5 points are your smallest number. From that nice little list there, what's our smallest number? 59. Okay, we also need our quartile 1, which we'll figure out in a minute. We need the median. We need quartile 3. And we need our largest data point, which that one we can figure out from our list here. All right. So we've got 75 for our largest also. Okay, from here, if you're going to do it manually, we need to find the median first. How many data points do we have there? 25 of them, right? Isn't that what you said?
No.
Well, that's right.
Oh,
All right. Yeah, it's right. Okay. So the middle number here would be this 65 right there. And that is our median. Okay. Now, how you guys have done it in the past, and you guys can do it however you want. Okay. I know some of you, what you did in the past was you crossed off your smallest and your largest, and then you went and you just kept going that way. Okay, until you got all the way to the middle number. Okay, if you want to do that, that's fine. Okay. All right, now, so we found our median there. To find our quartile 1, we have to take the median of the top half. So we've got 12 numbers here. We're going to have 2 of them then. So that means we're going to take our 6th number and our 7th number. Okay. Notice you have to use this 65 that I circled as your median. So even though we have more 65s below, that's okay. It's going to be part of below, or it's going to be part of that quartile 1 that we have to figure out. So these 2 are the same. So normally if you have 2 of them, you're going to average the 2 of them together. All right, because they're the same, it's just going to be a 63. All right, for quartile 3, same concept. It's going to be 2 of them because there's 12 above that 65. And they happen to be the same for this one also. It just happened to work out that way. All right, if they're different, you find the average of the two of them. Okay, once you have those 5 numbers, you just put them on a box and whisker plot. Okay, now what you should do, and I'm not going to make you do it, okay, but what you should do for this is you should measure this out the best you can. All right. So for example, we would say 63 is on the left side of the box. 70 would be on the right side of the box. All right. Now I'm not going to make you like count out every single number in between. Okay. Our median is going to go inside the box somewhere. 65 is going to be a lot closer to 63 than it is 70. Just show that there. Okay, and then right below that line, we put our median. All right, and then, so how many data points should be inside the box here? What percent? Whatever whoever said it. Yeah, it should be 50% of your data points. Should fall in between this 63 and that 70. Okay. All right, and then that means 50% of the data points fall outside of it, and that's where you put the whiskers on it. Okay, so we draw a line out here, okay, to approximately where 59 would go. Okay, and then on the other side, this one should be a little bit longer. And there you go. Okay, and that's all you have to do for your box and whisker plots. All right, so it's a lot of medians. It's 3 medians there, smallest number, largest number. And that is it. You guys have any questions? I assume once you start doing the homework, the questions will pop up a little bit more because they do it a little bit differently, or they word them a little bit differently. So be careful with that part.